These tools, okay, they're not new. They've got tens of thousands of GitHub stars, millions of downloads, big teams already running them in production. They just, I don't know, they never went viral. And that's kind of the whole problem, right? Because right now, you're probably rebuilding something that one of these repos already solved perfectly. So here's the countdown, 10 down to 1, and I'm ranking them by how much pain each one just deletes from your stack. Number 10 is Chonkie, and it solves a problem that, honestly, most people don't even realize is costing them quality. So if you're building anything with retrieval, a RAG pipeline, where the model looks up relevant documents before it answers, you gotta chop those documents into chunks first. Sounds trivial. It isn't. The way you split that text, it decides what the retriever can actually find. Split mid-sentence, and yeah, you just handed the model garbage context. Split too coarse, and you bury the one paragraph that mattered inside this wall of noise. And most people just write a text.split on every 500 characters and call it done. And then they sit there wondering why their answers are kind of mediocre. Chonkie's a tiny, fast little library that gives you actual chunking strategies instead of that naive split. So you got token chunking, sentence chunking, recursive chunking that respects document structure, semantic chunking that groups text by meaning, and late chunking, where you embed the whole document first and then split, so each chunk keeps the context of the words around it. And the point is, there's no single right chunk size, right? A legal contract and a Slack export, those want completely different strategies, and Chonkie lets you swap between them in a line instead of rewriting your whole ingestion code. It's lightweight on purpose, no giant dependency tree, fast enough to run over a big corpus without it becoming the slow part of your pipeline. The honest caveat though, it's a small, mostly single maintainer project, so, don't bet your company's core infra on it without reading the code first. But for the thing it does, it'll save you the day you'd otherwise spend hand-tuning split logic and rerunning evals. Use it the moment your retrieval quality plateaus, and you kinda suspect the chunks are the reason. Number 9, Marker, around 18,000 stars, and it exists because, well, the real world ships documents as PDFs. So here's the actual problem. Your knowledge lives in PDFs, EPUBs, Word files, scanned reports, research papers, manuals with these 2-column layouts, tables, equations, footnotes. And to feed any of that to an LLM, you need clean text. And PDF is one of the most hostile formats to extract cleanly. Pull text out with a basic library and you get, scrambled column order, tables flattened into nonsense, headers interleaved with body text. And then the model reasons over corrupted input, and surprise, you blame the model. Marker converts PDFs and other documents into clean markdown using machine learning models that actually understand page layout. It figures out reading order, keeps tables as tables, handles math, strips the junk. And the output's structured markdown that drops straight into a RAG pipeline or a long context prompt. On most benchmarks, it beats NuGet. That's the older meta model people used to reach for, and it's faster too. The trade-off, it's heavier than a plain text extractor because it's running ML under the hood. So for a stack of simple, well-behaved PDFs, yeah, it's overkill. But once your documents have any real layout complexity, tables, columns, scans, Marker's the difference between a pipeline that works and one that just quietly poisons every answer. If you're ingesting a corpus of real-world documents, this is the front door. Number 8, Langfuse. It's the open source observability layer for LLM apps, backed by Y Combinator, sitting around 7,000 stars. So once your app is more than one prompt, you kinda go blind. A user reports a bad answer and you have no idea which step failed. Was it retrieval? The prompt? The model? A tool called 3 layers deep in some agent? You're just grepping logs and guessing. Langfuse fixes that by tracing every LLM call as a structured timeline. Every prompt, every response, every tool invocation, latency, token cost, all of it captured so you can replay exactly what happened on any request. And on top of the tracing, it does evals, so you can score outputs systematically, and prompt management, so your prompts live in one versioned place instead of, scattered all over your codebase. The fork here matters though. Langfuse is positioned as the open source, self-hostable answer to Langsmith, which is LangChain's commercial observability product. So which do you pick? Go Langfuse if you've got data residency requirements, if traces of user prompts legally can't leave your infrastructure, or honestly you just want to own the stack and you've got the DevOps muscle. Because self-hosting it means running Postgres and ClickHouse, and that's real operational overhead. Pick Langsmith if you want the polished, hosted experience and your org doesn't care where the data sits, because honestly, its UX is ahead. So the open source argument, it wins on control and compliance, not on convenience. Just know which one you're actually optimizing for. Number 7, Qdrant, a vector database written in Rust, north of 20,000 stars. So embeddings turn text into vectors, which are just long lists of numbers where similar meaning lands close together in space. And to do retrieval at scale, you need somewhere to store millions or billions of those vectors and find the nearest ones to a query in milliseconds. That's a vector database, and Qdrant's one of the strongest open source ones going. And the Rust thing isn't a vanity detail, right? It means tight memory control and serious throughput, which is why it handles billion-scale similarity search without just falling over. You can self-host it or use their managed cloud, and it does the stuff production actually needs, filtering search by metadata, so you can say, give me the nearest vectors but only from this user's documents, payload storage, horizontal scaling. It's the vector store under a ton of RAG systems people use every day without even knowing the name. So when do you reach for a dedicated database like this versus just keeping vectors in Postgres with pgvector? Pick pgvector if your data's small, already lives in Postgres, and you want one less moving part. Pick Qdrant the moment scale, or filtering, or query latency becomes the bottleneck, which it will if you're serving real traffic over a big corpus. It's the upgrade you make when your prototype vector store starts to choke. Number 6 is Ollama, somewhere around over 80,000 stars by mid-2025, one of the fastest growing AI repos ever. Ollama makes running an open weight model on your own machine a one-command affair. Install it, type Ollama run llama 3, and boom, you've got a local model with an OpenAI-compatible API on localhost. And that compatibility, that's the clever part. Any code you wrote against OpenAI, mostly it just works by pointing it at your local endpoint instead. Its model library kinda exploded through 2024 and 2025. Llama 3.1, 3.2, 3.3, Mistral Nemo, Gemma 2, Phi 3, and 3.5, DeepSeek R1, Qwen 2.5. Basically any open weight model you'd want, one install away. Now, I gotta be straight with you, cause there's hype here worth calling out. The run local and save money pitch. It's real for some cases, and it's nonsense for others. For private data that legally cannot leave your network, for offline work, for cheap experimentation, for building desktop apps that ship a model to the user, Ollama's genuinely excellent. But the idea that a developer's MacBook running Llama 370B replaces a cloud API in production, that mostly doesn't hold. It's slower, less reliable, and a hosted call at fractions of a cent per thousand tokens beats it on both cost and uptime once you've got real traffic. Critics call the local everything fantasy developer cosplay, and yeah, for most production workloads, they're right. So the verdict. Ollama's a fantastic development and privacy tool, not a free production backend. Use it to prototype, to keep sensitive data in-house, to run offline. Just don't use it as your excuse to skip a real inference setup when you go to scale. Number 5, DSPy, out of Stanford's NLP lab, north of 20,000 stars. And it attacks the thing every builder secretly hates, prompt engineering. So here's the pain. You handwrite a prompt, you tune it for hours, it works. Then the model version changes and your carefully crafted wording just breaks, because it was tuned to quirks of the old model. Your whole pipeline's a stack of brittle strings held together by, I don't know, vibes. DSPy's argument is that you should program your LLM, not prompt it. So you define modules with typed inputs and outputs, the logic of what you want, and then DSPy's optimizer writes and rewrites the actual prompt text for you, automatically, against a metric you give it. The optimizer in DSPy 2.0, it's called MiPro v2, it can tune multi-step, multi-metric pipelines. So this scales past toy single-task examples into real agent systems. Teams like JetBlue and Replit have run it in production. And the concrete win is self-improving pipelines. Instead of a human babysitting prompt strings forever, you specify the behavior and a metric, and the system tunes itself. When the model changes, you just rerun the optimizer instead of rewriting prompts by hand. The honest catch, though, and the critics have a point here, is that the optimizer is a black box on top of a black box. It changes your prompts under the hood, so when something goes wrong, it's harder to debug. And some teams genuinely prefer explicit, version-controlled prompt text they can just read. So fork it like this. Reach for DSPy when you've got a complex pipeline, a clear metric to optimize against, and you're just tired of manual prompt churn. Stick with handwritten prompts when the task's simple, and you value being able to read exactly what's sent to the model. It's a power tool, and, you know, like any power tool, it rewards people who already understand the problem it's automating. Number 4 is Crawl for AI, and it's the most starred open source crawler on GitHub, which kinda tells you how badly people needed it. So the origin story is the value prop. The creator, who goes by Uncle Code, he got fed up with paywalled, gated scraping services charging him to pull public web data into AI pipelines. In his words, he went turbo anger mode, built Crawl for AI in days, and it went viral. No API keys forced on you, no paywall. And what makes it AI native instead of just another scraper? It's the output. Most scrapers hand you raw HTML, and then you spend an afternoon stripping tags, navbars, ads, scripts before the text is even usable. Crawl for AI outputs clean markdown designed for RAG and LLM ingestion. It also does structured extraction by CSS selector, XPath, or by handing a schema to an LLM, plus parallel crawling, stealth mode to dodge bot detection, proxy support, and session reuse so you can crawl behind a login. It's gone enterprise grade too, hitting the V0.9 line with a partnership claiming 99.9% uptime. The thing to watch is sustainability. This started as a single maintainer's Fury project, and the creators now actively seeking enterprise sponsors, which is, honestly, the signal that volunteer maintenance doesn't survive production-grade load. Don't read that as a reason to avoid it, though. Read it as a reason to pin your version and watch the project's health. For getting web content into an LLM pipeline as clean markdown, with no gatekeeper between you and the data, nothing open source does it better right now. Number 3, outlines from .txt. And this one, it kind of changes how you think about reliable output entirely. So here's the setup, and it leads straight into number 2, so pay attention. When you need an LLM to return valid JSON or match an exact format, the normal approach is you ask nicely, check the result, and retry if it's broken. Outlines just refuses to play that game. It constrains generation at the token level, during generation, so an invalid token literally cannot be produced. The model picks the next token from a probability distribution over its whole vocabulary, right? Outlines masks out every token that would violate your schema before the model chooses, so at every single step, the only options left are valid ones. And the result is mathematically guaranteed valid JSON, or a regex match, or one of your allowed enum values. Not fixed after the fact, impossible to get wrong in the first place. And that guarantee comes at effectively zero latency cost, because you're not running retry loops, and that's why it's been adopted where it counts. LLM, Hugging Face's Text Generation Inference, SGLang, the 3 dominant open source inference servers, they all integrate outlines natively. So that means constrained generation is now a first-class feature across hundreds of organizations serving infrastructure, not some niche plugin you bolt on. The one hard limit, it defines exactly when you use it. Outlines works by reaching into the token probabilities, which means you need a model you serve yourself, an open weight model behind LLM or TGI. You cannot do this to GPT-4o or Claude through their APIs because you don't control their token sampling. So the fork kind of writes itself, and it's the whole reason number 2 exists. Number 2 is LiteLLM, the unified gateway that ends provider lock-in. So every provider has its own SDK, its own request shape, its own quirks. Write your app against OpenAI, then your boss says, move to Claude for cost, or to Bedrock for compliance, and now you're rewriting integration code all across your codebase. The founders at Berry AI built LiteLLM after watching enterprise teams burn weeks on exactly that switching logic. It gives you one OpenAI-compatible interface that routes to over 100 LLM APIs. OpenAI, Anthropic, Bedrock, Azure, Vertex, Cohere, Hugging Face, NVIDIA NIM, the long tail, all of it through one shape. So swapping providers becomes a config change, not a code rewrite. It comes in 2 forms, and picking the right one matters. There's the Python SDK you import directly into your app, and there's the proxy server, the AI gateway, that runs as a central service every team in your company calls. The proxy adds cost tracking, guardrails, load balancing, and logging across providers in one place, and it covers basically every endpoint in production use. Chat completions, the responses API, embeddings, images, audio, batches, re-rank, even the new agent-to-agent endpoint that tracks the emerging A2A protocol for routing traffic between agents, not just to models. Now, be careful with the proxy. Running it as a centralized gateway, that introduces a single point of failure, and teams have hit rate limit handling bugs and inconsistent streaming across providers under heavy load. Berry AI added Redis-backed rate limiting and active health checks in response, but the criticism, it persists at high throughput. So fork it. Use the SDK inside a single service for simple provider flexibility with no extra infrastructure to babysit. Stand up the proxy when you've got many teams, many providers, and you need centralized cost and policy control. And when you do, give it the redundancy any single point of failure demands. Either way, this is the repo that keeps you from, marrying one model vendor. Number 1 is Instructor. Over 11,000 stars, more than 3 million downloads a month, over 100 contributors, and it got there on pure word of mouth among ML engineers with basically no marketing. It's number 1 because it deletes the single most universal piece of boilerplate in the entire LLM stack. So you ask a model for structured data, it hands you back a string. Now you parse that string into JSON, validate the fields, handle the case where it wrapped the JSON in prose, handle the missing field, handle the wrong type, and write a retry for when it's malformed. Everyone writes this. Everyone writes it again on the next project. Jason Liu, a former Stitch Fix ML engineer, he got sick of rewriting it and built Instructor so he'd never have to again. And here's how it kills the boilerplate. You define a Pydantic model, which is just a Python class describing the shape you want, names, types, constraints. You pass it as response model to your LLM call, and you get back a validated Python object. No JSON parsing, no error handling, no manual retries. Because validation and automatic retries are built in. If the model returns something that doesn't fit your schema, Instructor catches it and retries with the validation error fed back to the model until it conforms. It's built on Pydantic v2, whose validation core was rewritten in Rust for roughly 17 times speedup, so the checking's fast. And it's not just Python either. There are ports for TypeScript, Go, Ruby, Elixir, and Rust. This is also the other side of the fork from outlines, and now you can see the whole picture. Instructor fixes outputs after generation with retries, which means it works against any model through any API, including GPT-4o and Claude, the closed ones where you can't touch the token sampling. Outlines prevents bad outputs during generation with a hard guarantee, but only on open weight models you serve yourself. So the decision's clean. Calling a hosted API like OpenAI or Anthropic? Use Instructor, because post hoc validation with retries is the only option you've got, and it covers 99% of production cases. Serving your own open model on LLM and you want a mathematical guarantee at zero latency cost? Use Outlines. Most builders, they're calling an API XI, which is exactly why Instructor's number one. It's the highest leverage import you can add to an LLM project today. One clarification, because it tripped people up in late 2024. Instructor moved to the 567 Labs organization on GitHub and now draws a clear line between itself and Pydantic AI. Instructor is for schema-first extraction, pulling structured data out of a model. Pydantic AI is for building agents. So if you just need clean, validated data back from an LLM call, Instructor's the one you want. So that's the 10. None of them are secret, they just never got the hype they earned. And if you take one thing away, it's this. Before you write another JSON parser, another provider switch, another retry loop, another chunking function, just check whether one of these already solved it. Because the model layer, it's a commodity now. The glue code around it is where you actually win, and these repos, they're the glue. Stop rebuilding it.